we're going to take the derivative of p with respect to q. So here's p, I've got a q here and a q there. It's in the form of a fraction, so we're probably going to do the quotient rule here. So dp dq, or p prime, is going to be the bottom times the derivative of the top. Going back, the derivative of tangent is a squared function. It's going to be secant squared q. So bottom times the derivative of the top minus the top times the derivative of the bottom. Well, the derivative of 1 is 0, and the derivative of tangent again is secant squared q, all over the bottom squared. Okay, let's keep going here. So p prime is, it looks like might be this kind of the same situation we got above, so let's multiply it out as secant squared q plus tangent q times secant squared q minus tangent times 0, which is 0, and then minus tangent q secant squared q all over 1 plus tangent q squared. So a positive tangent secant squared cancels with the negative tangent secant squared, and what we have left is p prime is equal to secant squared q over 1 plus tangent squared. All of that, or 1 plus tangent q, then all of that squared. Okay. And kind of just check in one more time. 1 plus tangent here, this base of the exponent part here doesn't really cancel. It doesn't have any kind of identity, so it's not like 1 plus tangent can make a secant or something like that. So it's looking like that even if I multiplied out that denominator, you'd get 1 plus 2 tangent q plus tangent squared q, and nothing there is even going to cancel that numerator. So we can probably box this up and call this problem done. Okay, going to example 5. We want to graph y equals tangent x on the interval of negative pi over 2 to positive pi over 2, and then we want to graph the tangents for x equals negative pi over 3, 0, and pi over 3. Okay, so to get this problem started, why don't we first do the first thing they ask us for, and let's graph tangent x on the interval. Okay, and I know a lot of us already know what the graph looks like, but let me go ahead and do an XYT chart because we're going to probably come back and use some of these points here to get the second part of this question. So from negative pi over 2, let's go from there. How about the negative pi over 3, negative pi over 4, about 0, pi over 4, pi over 3, and then pi over 2. Okay, so at each of these, let's find the tangent. The tangent of 0, the y value there is 0 over 1, which is 0. Okay. The tangent values at pi over 2 and negative pi over 2, y over x, so it would be 1 over 0 or negative 1 over 0, which we're getting our undefined, so that's where we're going to get our asymptotes, our vertical ones. Okay, let's go to the next easiest ones, the pi over 4s. The ratio of square root of 2 over 2 and square root of 2 over 2 is going to be 1. And then at the negative pi over 4 will be negative 1. Okay, so if we look at pi over 3, the tangent value at pi over 3, well, the coordinate value there is 1/2 and then square root of 3 over 2. So if we take y divided by x, we'll just get the square root of 3. And then the negative square root of 3, which is approximately negative 1.7. And then positive 1.7. Okay. So from there, let's put all these points, technically, on the xy axis and get ourselves a graph. So if we call, how about that, negative pi over 2? Over here we'll make positive pi over 2. Half that way, pi over 4s. And then we've got a 1 and a 2. And negative 1, negative 2. So I have my asymptotes at negative pi over 2 and positive pi over 2, where my graph is undefined. I cross at the origin, and at pi over 4, I'm up at 1, and negative pi over 4, I'm down there. And then at pi over 3s, I'm at about 1.7 and negative 1.7. So I got my curve coming up, which is good. All right, so that looks like our normal tangent graph. So there's the first part. Now we want to go about and actually graphing the tangents. And remember, the tangents are all based on using the derivative and using the slopes and everything. So first things first, if y is equal to tangent of x, then y prime, what's the derivative of tangent x? Well, it's secant squared x, okay? And in order to get, let's first focus on how about that x equals, let's go with just x equals 0 first of all, okay? So at x equals 0, let's find the slope. So then y prime is going to be secant squared of 0, or if you want to treat it as 1 over cosine squared evaluated at 0, which is 1 over 1. So the derivative, or the slope, at x equals 0 is 1. So you can think about it as m equals 1. Okay? Well, what's the point at 1? We have a slope of 1. The coordinate there at 1 originally is 0, 0. So now we can write our equation. Y minus y1 is equal to m times x minus x1. So at the point 0, so at x equals 0, the equation for my tangent line is y equals x. So let me go ahead and box that up. We're going to definitely use that here in a second. Continuing this same process, let's find it for, let's see, x equals pi over 3. Okay, so the derivative to help me find the slope is going to be secant squared of pi over 3, which is 1 over the cosine at pi over 3. Okay, so that's saying that my derivative there, or my slope, is 1 over the x value, which is 1/2. So it looks like it's going to be 2. So in that case, m equals 2. And if we go back to our linear stuff that we know, if I have a slope at 2, the point there is, going to our chart, is pi over 3. And I guess if we want to write it as the square root of 3, then it's y minus the y value is equal to m times x minus the x value. Okay, and then just kind of cleaning this up, that if I solve for y, and you'll get y equals 2x, go ahead and go 2 times the negative pi over 3, and let's move that square root of 3 over real quick. We'll get our y-intercept. It's kind of round in here. I'll go a negative, it's negative 0.3623, so I'm going to go a negative 0.4. Okay? And like we did before, let's go ahead and box this one up, because this represents the equation for our tangent line at pi over 3. And you know what? We're probably going to get something very, very similar to this whenever we go to x equals negative pi over 3. Okay. So y prime, again, is just the secant squared of negative pi over 3. And that's going to be 1 over the cosine of negative pi over 3. And the cosine of negative pi over 3 will give us a y prime equal to the exact same thing as we did before. So it's going to be 1 over 1/2, or 2. So m equals 2. So if we take that slope of 2, and then we use the same, almost the same coordinate, in the sense it's going to be the negative pi over 3, and the y value there is a negative square root of 3. Let's form our equation, and we can be done with this part. Well, and if we finish this up just pretty much doing the exact same steps we've done before, you'll get a y equals, y'all can follow me through this, but y equals 2x, and then this time it's going to be a plus 0.4. Okay, so let's box up this last one, and then all we need to do is take these 3 equations and graph them on our graph. Okay, well, look at this first one, this tangent line. So the tangent at x equals 0 is y equals x. And if we kind of go up to the graph, you can really see it there. You know, a graph, it would normally go through 0, 0, 1, 1, negative 1, 1. So you can see how it really is a true tangent line. So it's really hitting right on that graph, right where it should. Okay, so that's that tangent line, y equals x. And if we go the next two, I've got one, they both have a slope of 2. One's got a y-intercept at basically negative 1/2, and one's got a y-intercept of positive 1/2. Okay, so at pi over 3, let's see here, let's go down to a y-intercept of negative 1/2. Maybe right about there. Okay, and then from there I've got to go up 1 and right 2. I just said up 1, right 2, but this should be a slope of 2, so up 2, right 1. So there's 1, 2, and right 1. If I kind of draw a line connecting those two, we're going to cross our plane there, but it's running tangent at about pi over 3, okay? And if we do the same thing for the other one, you're going to get one of about 0.4, then up 2, right 1, and you'll eventually get one of your other tangent lines. I'm kind of running out of room all throughout here, but then you can see, anyways, just take these 2 lines down here, just graph them on there. If I maybe opened up my window just a little bit more so you can really see in depth, but y'all are seeing how I'm drawing those tangent lines, and they would be on that graph as well. All right, let's go on to the next lesson.